Hi everybody, this is Professor B.K. Navle from Bivrabai Sawant College of Engineering and Research, Nare, Pune, and today we will be seeing the assignment 2:1 MUX using transmission gate from subject VLSI Design and Technology. As we know, the transmission gate consists of P MOSFET and N MOSFET connected in parallel fashion. Okay, when C is equal to 1, A is passed to B, and when C is 0, in that case both P MOSFET and N MOSFET will act as an open switch and A is disconnected from B. Okay, this is the simple working of transmission gate. Now this diagram is the 2:1 MUX using transmission gate. So when S is equal to 0, this transmission gate is in conduction state and we will get Z is equal to A, and when S is equal to 0, S bar will be 1. That's why second transmission gate is in conduction state and we will get B at the output. So we can say this circuit will work as a 2:1 MUX. Now we will go to microwind and try to implement 2:1 MUX using MOSFET. Now in this case we require both S and S bar. So to invert the select line, I have implemented one inverter. This inverter is used to invert the select line, and this will be act as a transmission gate 1 and this will be transmission gate 2. Okay, let's connect them all together. First we will assign select line to inverter input, and from inverter we will get inverted output also. Now we have to connect P MOSFET of transmission gate 1 to N MOSFET, and we have to apply S bar, and to the N MOSFET of transmission gate and P MOSFET of transmission gate 2 we have to apply S. Let's do the connection in microwind. So in this case, in this layout I have did the connection already. I have connected the P MOSFET of transmission gate 1 to the N MOSFET of transmission gate 2, and N MOSFET of transmission gate 1 is connected to P MOSFET of transmission gate 2. Now we have to connect select bar, that is the output of inverter, to the N MOSFET of transmission gate 1. Now as there is a connection between metal 1 and polysilicon, we have to place contact here, metal to polysilicon contact. Okay, now we have to connect P MOSFET of transmission gate 1 to the select line. So I will extend this select line, and by extending this point I will connect them to each other. Okay, all the connection we have did. Now we have to apply input A and B to transmission gate 1 and 2. So we will be applying input 1 to transmission gate 1, and now we are applying clock as a input 1. Okay, and we will make it more faster than select line. Assign. Again we have to apply second input to the second transmission gate, let's say in 2, and assign, and we can see the output at the common point. Here we can see the output. So go to visible node, add that node to the common point of both the transmission gate. Let's say the title is Y. So when ACL is equal to 1, this P MOSFET is in off state and this N MOSFET is in on state. Similarly, when ACL is equal to 1, ACL bar is 0, and due to which this P MOSFET will be on. That's why in2 will be passed to Y. And when ACL is 0, both P MOSFET 1 and N MOSFET 1 will be on, and in 1 is passed to 0. Now let us check the DRC. Okay, as there is no any design error, we simulate the design. Click on run simulation and you can see the output waveform. Okay, when select line is 0, output is following in 1, and when select line is 1, output is following in 2. You can also observe the power dissipation is very much less in case of transmission gate. Okay, in case of a conventional method, the power transmission is near about 15 to 16 microwatt. Right now it is 1.331 microwatt.